Today's video is Lesson 9 of Unit 11. We'll be covering pages 380 and 381. You want to have your graphing calculator and a colored pencil would be helpful. Finally, we're putting this all together and looking at real world problems. So let's go over everything we know so far and all the formulas you need to know. So for our modeling, remember our coefficients? Our y equals a sine bx plus c and y equals a cosine bx plus c. The absolute value of a is the amplitude, or the distance the sinusoidal model rises and falls above its midline. And we want to know that a is equal to the max minus the min divided by 2. See the midline or average y value of the sinusoidal model? Unless it's the average, it's a max plus the min divided by 2. B, the number of cycles in 2 pi related to the period, capital P. By the equation, we use B equals 2 pi over P. And the period is a minimum distance along the x-axis for the cycle to repeat. Period is the length of one full cycle. Period equals 2 pi over B. And let's also put in our range. Remember, our range is equal to C plus or minus the absolute value of A. In which case, if we're looking for our maximum would be C plus the absolute value of A, and our minimum would be C minus the absolute value of A. None of these formulas are given to you. You have to memorize all of them. Okay, here we go. Our first exercise. The tides in a particular bay can be modeled with an equation of the form lowercase d equals a cosine bt plus c, where t represents the number of hours since high tide and d represents the depth of the water in the bay. The maximum depth of the water is 36 feet, so the max is 36. The minimum depth of the water, the min, is 22. And high tide happens every 12 hours. This every 12 hours is our period. The length of one complete cosine cycle for this scenario. On the axis, graph a sketch of this scenario for 2 full periods. So for 2 full periods, so 2 times 12 is 24. So we have to go out to a length of 24 on our time. So we'll put 24 here, and then just judging midway, 12 here. So from 0 to 12 hours, there'd be 1 cosine, and then a second one from 12 to 24. Let's go half of 12 is 6, and halfway between 12 and 24, 18. Label the points on this curve that represent high and low tide. Determine the values of A, B, and C in the model. Okay, so we know that high tide is 36, and we're starting at high tide. So let's label this. I'll put a 36 here, and trying to judge halfway would be, this would be about 18. And the minimum depth is 22. Okay. So 36 feet is the depth. After 12 hours, we are back at 36. midway between. At 6 hours, we are at low tide, which is about here, 22. Here we go. Here's a sketch. Here's our one complete cycle. And then from 12 to 24, we get a second. Label the points on this curve that represent high tide. Alright, so this high tide and then these 2 points down here are low tide. So that's 18:22 and 6:22. 0:36, 12:36, and 24:36. Determine the values of A, B, and C. Verify your sketch is correct using a calculator. A equals max minus min divided by 2. Max is 36, minimum's 22, 36 subtract 22 is 14, divided by 2 is 7, so A is 7. B equals 2 pi over P. P is 12, 2 pi over 12 reduces to pi over 6. C equals max plus min divided by 2. 36 plus 22 is 58, divided by 2 is 29. So we want to verify this sketch using our calculator. So we'll go to y equals A cosine B, we will use x instead of t, bx plus c. So y equals 7 cosine pi over 6 x, close parentheses, and plus 29. Now the window, x's are going from 0 to 24, and I went by 6. And for y, 0 to 36, and I didn't go by anything. I think I'll just put down 2's. Okay, this graph matches our sketch. Looks good. Tanker boats cannot be in the bay when the depth of the water is less or equal to 25 feet. Write an inequality and solve it graphically. Determine all points in time, t, on the interval from 0 to 24 when tankers cannot be in the bay. Alright, so that means when it's less than or equal to 25 feet. So the inequality would be that our equation, which I didn't put it up above, let me just write down here what we put into the calculator. Y equals 7 cosine pi over 6t plus 29. So our inequality would be that this when is it less than or equal to 25? So using the calculator, in y1 we will put the left hand side, we'll put 7 cosine pi over 6t plus 29, and in Y2, this is where it's helpful to have a different colored pencil. We'll put in 25, and then we will second trace and find the intersect. As we have to determine all points in time when the tankers cannot be in the bay. So when time is what? Between what and what? So y sub 2, 25. And actually on our sketch, say 22, oh wait, it's 25 is about here. Let's just draw this. So from here to here, those tanker boats cannot be in the bay because that's when it's less than 25 at or below 25 feet. From here to here, and then from here to here. Okay, so second trace, number 5. Again, please make sure you're doing this on your own calculator, not just watching me do all the work. First curve, enter. Second curve, enter. Guess, enter. Took me to that point. So to the nearest tenth, 16.2, comma 25. Second trace, number 5. Enter, enter. For the guess, movement closer to the other point. 19.8. So that's one interval of time. So t has to be greater than or equal to, no, it has to be greater than or equal to greater than, not equal to, greater than 16.2 and less than 19.8. And then let's do the same. Second trace, number 5. Enter, enter. Let's get the other two values. .2 to 7.8. One cannot be in the bay. All right, so let's, yeah, they should have the equal to. I was thinking one can be, one cannot be in the bay. So these two inequalities are our answers. Oh, or just remember that we could have interval notation, 4.2, comma 7.8 in brackets, and 16.2, comma 19.8 in brackets. Exercise 2, the height of a yo-yo above the ground can be modeled using the equation lowercase h equals 1.75 cosine pi t plus 2.25, where h represents the height in feet above the ground and t represents time in seconds since the yo-yo was first dropped from its maximum height. Determine the maximum and minimum heights. Show your calculations. Okay, so we have our equation A, B, C. Our max, remember, is C plus the absolute value of A. So in this case, 2.25 plus 1.75 is 4, so that's 4 feet. And our formula for min is C minus the absolute value of A. 2.25 minus 1.75 is 0.5 feet. So there's our max and our min. How much time does it take for the yo-yo to return to the maximum height for the first time? So it's asking us, what is the period? What is the period? Formula, period equals 2 pi over b. B is pi, so 2 pi over pi is 2 seconds. Exercise 3, we've got a Ferris wheel is constructed such that a person gets on the wheel at its lowest point. So it starts at its lowest point, the minimum, which is 5 feet above the ground. So the min is 5, and reaches its highest point, so this is its max, of 130 feet. It takes 8 minutes to complete one full rotation, so the period is 8. A person's vertical position, y, can be modeled as a function of time, t minutes since boarding, by the equation A equals cosine b t plus c. Sketch a graph of the person's vertical position from one cycle and then determine the values of A, B, and C. Alright, so the period is 8 minutes. The 8 here, judging about halfway, about 4 minutes. And the max is 130, and the min is 5. And they start at the min, so it starts at time 0. We're at a height of 5. And then after one complete cycle, which is 8 minutes, back where we started from. And then halfway up to the max of 130. So there's our sketch. A equals, make sure you keep writing the formula, max minus min divided by 2. 130 minus 5 is 125 divided by 2 is 62.5. B equals 2 pi over P, 2 pi over 8, just pi over 4, and C equals max plus the min divided by 2. 130 plus 5 is 135 divided by 2 is 67.5. Now, let's write the equation. Y equals, now the only thing here is that it's starting at its minimum, right? Its midline is about here, and it's starting below that midline, so the equation would actually be y equals negative 62.5 cosine pi over 4t plus 67.5. That's our equation. And we could use a graphing calculator to check it if we want. And our last exercise, the possible hours of daylight in a given day is a function of the day of the year. The minimum hours of daylight on the winter solstice is 9 hours. So we have a min of 9. And the maximum hours of daylight on the summer solstice is 15 hours. If the hours of daylight can be modeled using a sinusoidal equation, what is the equation's amplitude? A equals max minus min divided by 2. 15 minus 9 is 6, divided by 2 is 3. Once again, thank you for your attention. Make sure you've got to memorize all of these, all 5 of these.